Hey Nico, good afternoon.
Hello.
Waiting on Jamie, I believe.
Yeah, 1 second. Let me text him and see if he's
Sure.
having trouble getting in.
If you need the link, let me know.
Okay. I'm finding some problems right now on WebAssign.
Great.
Yeah.
I see that Jamie entered the room here. Hey
Hello.
Jamie, it's Matthew. How are you?
Good. Sorry
Ni-
about that.
Nick,
I lost track of time.
no problem. Nico is already in the room. As always, you can either chat what you want to work on, what you want to work on, or I will send you the email here to send it to, and just waiting on some content to help you guys out. Nico said he's going to put together some WebAssign problems. Let me know what you want us to work on today.
Okay, I just sent some over to you.
All right, I will take a look here.
Thank you.
All right, Nico, looking this over here, I'm seeing some matricey stuff. Okay, I mean, there's so many here. These sometimes are quite lengthy in time. So we may have to prioritize some of these.
I mean, if we don't have time, if you can just tell me like, I guess I mean, maybe just like steps or concepts to it, because there's some that just,
Of course, yeah.
that's perfect.
Jamie, are you gonna send some over or do you want me to just start here with some,
I got my pictures. I'm just
Yeah.
uploading. Go ahead and start.
Let's start with, I guess 7. The hardest thing on these is to set up the actual system of equations, and then from there, you if you can set it up correctly, then you just solve using your calculator or software or something. Let's see if I can make this a little more readable. Okay, I'm going to share my screen and we'll get started here.
I just sent mine in too.
Okay. All right, so looking at this question here, consider an investor with a portfolio. That's the total that's deposited, and they tell you here, I'm sorry for the weird scaling. This just didn't fit well on my screen. So they're telling you there's 1, 2, 3, 4 types, and the variables here help. They actually tell you what the variables are. So you know, that's somewhat useful. Okay. So let's see here. So again, kind of just setting up the equations is the big thing here. And this is probably what makes this most difficult. So we need, because there's 4 variables, we need 4 equations. The first one is the total equation. There's almost always one of these, and I'm just going to do it in the order that it appears here. Okay. And you're essentially looking for like numbers or the red stuff, but so they tell you what the returns are. Certificate deposits pays 5%, bonds pay 5%. Over a 5-year period, the investor expects the blue chips to return 12%, 6%. They want a combined annual return of 10%. Okay, so based on that last sentence there, that they pay the returns, they're telling you, okay, 0.09. Oh, these are out of order. Oh, bless it. Okay. Let me see here. Certificate. No, that's right. So 0.09C plus municipal bonds 0.05M plus 0.12B plus 0.16G equals, because they want a 10% annual return, that's 10% of this amount here. It's 0.1 times 520,000. They also only want 1/4 of the stocks, 1/4 of the portfolio invested in stocks. So that means that the stocks are the blue chip and the speculative. So that's B plus G has to equal 1/4 of 520,000. Is that okay?
Perfect.
What I'm bothered by, and I'm tempted to just put this in a matrix and solve it, is I'm not seeing a 4th equation. Unless it's over a 5-year period, unless that's this as well. I don't think so though. So are you guys doing this in your calculator or using other software? What are you doing for solving this?
A calculator.
Calculator. Okay. Let me, before I go to a regular calculator, let me just see if I can get this to solve on my side, see if it actually has a solution. Because it really shouldn't based on what I'm seeing, but let me just do it real quick here and then fill you guys in on what I see. Okay. Yeah, so when I run this through my this is one more time. I'm not getting a solution because I don't have enough equations. Let me see if this problem has if there's something I'm missing here. As you guys probably know, there's a lot of information out there in the web on this stuff. So let's just see. But the general sort of solution here is to write the equations and then hopefully get this. So maybe the part that I'm missing here is that if b plus g equals a fourth of it, that means c plus m has to equal 3/4 of 520,000. Maybe that's what's implied there. So let me just run that through and see if that makes this any better. I don't know why that wasn't clear to me from the beginning, but it's a consequence of the other part, yeah. So this one is actually dependent, it looks like. And the reason is let me snip in what I see. I don't know how fast you guys are on your calculator, but are you doing stuff in matrix with matrices in your calculator?
Yeah, we've learned how
Okay.
to do that. Yeah.
Okay. So when I enter this, I get the following. Whenever you see a line full of zeros, that means that it's dependent. So then there's this thing called the free variable. And they say let G equal S. Okay, so that's S. So the way you interpret this is that this third line here, this third line corresponds to, let me put it here because we'll work backwards. This third column is B. It's B plus S equals 130,000. So B is equal to 130,000 minus S, because you just subtract it from both sides. And that's what goes here. Niko, since this is your problem, I mean, are we able to just try that G is S?
Yeah, I'll try it right now.
And does that just before I go much further? And then Jamie, yours will probably be the same because these problems are designed this way.
I put it in, it's loading right now. I'll let you know.
Okay.
Yeah, it's correct. That's correct.
Okay. So then from the second line 2 here, what that says is the second column corresponds to the second variable M. So it says M plus, I'm sorry, minus S because it's -1 here equals -325,000. So then M is equal to -325,000 plus S, or 32,500. I got the extra zero in there. So that is what goes into the into that third position, S minus 32,500. And then the first row there, and now we're going backwards. Okay, so the last one there, let me get that up. I know you can't see that, but the last one is C plus S equals 422,500. So then it's just subtracting again. So C equals, is it 40? Yeah, 420. So it's 422,500 minus S. That's that last one there. So
Okay, perfect.
okay. It's Jamie, did you happen to send one just like that?
Same one.
And do you have different numbers?
I do.
Okay, let me see if I can show you. I mean, the numbers map the same way in yours. So let me just snip that in and we'll write the equations and I'll print the solution here. Excuse me, and then we'll grab one of yours to work on next. Okay, so the it's C plus M plus B plus G equals 410,000. That's the same. And then they give you the interest amounts for each 0.05 M plus 0.12 B plus 0.14 G equals 10% of the 410,000.
Yep.
The next one here is that they only want 1/4 of the stock in the, or 1/4 of the portfolio in stock. So that's the last two. So that's 1/4 of 410,000. And then that means that 3/4 of 410,000.
Got it. Okay.
And I'll let you kind of work it from there. So let me grab another one from your set. If you have a preference, let me know.
Reload. Probably number 14. It's probably a good one to look at. For mine. Any of them really work.
Okay, so let me just grab one. To go back and forth here. Let's do this golf one. Is that okay?
That works.
All right. Is the question all there? Because it kind of looks like it's getting cut off on the right, but I can't. I think it's okay.
Oh shoot, yeah, it looks like a word got cut off. Oh yeah, it says there are 7 times as many par fours.
Yeah.
You want me to take a picture and resend it, or?
So no, I think I got it. 7 times as many over here. Okay. So an 18-hole golf course, they don't give you any variables, so we're just gonna use X, Y, and Z.
Mhm.
So the first thing is that X plus Y plus Z equals 18 because there's 18 holes. Okay, and then now we get into the part where it's like, okay, there's 7 times as many par 4 holes as par 5 holes. So what that means is that it's either y equals 7z or z equals 7y. Okay, so which one is it, or which one makes more sense here? And sometimes you get to put numbers in.
So it looks like it's, so it says there's 7 times as many par 4 holes as par 5s.
Right.
That would mean it's the par 5s, yeah.
So like I'm asking which one is this correct? And Nico, if you've got an idea, you can jump in, but sometimes it's good to put in a number. Like, let's say z is 1, then that means that y is 7. And is that what it means? Is 7 par 4s and 1 par 5? Is that what it's talking about?
No,
Mm-mm.
there's 7 times as many, so it'd be the other way.
There's 7 times as many par 4s, right? Y is par 4s. So what I'm trying to Jesse is this
Oh,
right? I
wait,
think
no,
you told me the
I
other
had
one.
I had it the other way around. Yeah, no, you're right. My bad.
Alright. Now, like I try to show this way. Maybe it was obvious to you guys, but like over the years, I've seen how this isn't obvious. So just keep that in mind. I'm sorry, we didn't do this. The sum of the number of par 3s and par 5 holes. So that's x plus z is 4. So like Nico, on your problem, oh, I'm sorry. I didn't see this here. Sorry, I didn't see it. So it's 3x plus 4y plus 5z equals 72. And that's this first equation. That's this. So whatever yours is, Nico, that 72 goes there.
Okay.
The
Actually,
fact that there are the sum of the number of par 3 and par 5 holes, that's x plus z is 4. And then that's 7 times whatever your number is will be replaced with that there. Okay. Are you guys comfortable entering this into the calculator? Or would you like me to show you how to do that for this one?
Can you show
Yes.
me? Yeah.
Yep. Just looking for yay or nay on that. So let me go and grab this calculator tool. And I'll write so if you don't have these equations down, actually one more comment here is you actually have to move the 7z over. So it's 3x plus 4y plus 5z equals 72. And then it's y minus 7z equals 0. And then x plus z equals 4 here. And then I'm going to share my switch to the other screen and go from there. Again, yours might be slightly different, but most of the combinations are the same. So you're going to go to math. Nope, you're going to go to second matrix. And you're going to edit. You're going to go to the right. You're going to edit A. And it's row by column. So this is 3 rows and it's 4 columns. And if you're wondering how many columns, it's always the number of variables plus 1. Okay. So there it is. So then if you don't have it, if you don't have a variable there, you have to hit enter. If you don't have a variable, which doesn't apply to the first row, 3x plus 4y plus 5z equals 72, you just leave it empty. So the next one is 0x plus 1y minus 7z, and then it equals 0, so you leave that. So then we go to the third row. That was the 1x plus 0y plus 1z equals 4. Okay. Any questions on this part? Anything you'd like me to go over again on this? Okay. So then you quit out of this second matrix again. You have to actually grab the matrix. You have to like hit enter. Okay. And if you hit enter, it'll display the matrix, which isn't what you want, but that's how you go back and grab the matrix. So you have to go back to second matrix to actually get your math functions on it. And the one you want is RREF Hopefully your instructor just told you to use that one all the time. Okay, and then you need to grab matrix A. So you go back, and it's a little cumbersome, but you got to go back at second matrix again, hit enter, grab it. And this is reduced row echelon form, which is what you want. So you should see something like that on your screen there. So let me snip that in to our workspace, and then we'll talk about what that means for your answers there. Anything you want me to review on the calculator before I jump out of this?
I think I'm good.
Okay, hopefully you got the same numbers. If you didn't, try it again, or we can do it again. So going back to the other screen here. So again, like the first row, I'm sorry, the first column is X, second column is Y. And I should even write that X, Y, and Z. So the first one means X equals 2. The second one means Y
Got it.
equals 14. Z equals 2 there, okay? And if you get weird numbers over here on the right, check, check that you didn't enter a negative or you missed a position. That's why I printed out the matrix above it, just to make sure it was exactly what I thought it was.
That makes sense.
Okay, Niko, if you're able to follow along, yours will be really similar. You get to choose the next problem we work on.
Check the one I sent you. Forgot the number, but it was the most confusing one that I had. I think it's, can we do 15?
Knew you were gonna go over that one. I gotta
Yeah.
look up these traffic flows. I don't even know what this means. This is a state diagram, and yeah, I'll do my best here to do this. I actually don't see any red, so maybe it's the same for both of you guys. Oh, they're down there in the bottom when
Yeah, they're in
X2.
B and C.
I see. All right. Okay, so X1, X2, X3. Oh man. Yeah, let me I gotta look this one up. I haven't done one of these in a long time.
Oh, I have this one done if you want me to help.
Absolutely. Talk me through it.
So I actually got help from our math teacher on this one. But so what it is the arrows on the lines there are like inflows and outflows.
Okay.
The starting value, like in the top left dot, is 300.
So like this.
X, yeah.
So in has to equal the 2 outs.
Yeah.
Okay. That's totally reasonable. So that's from the first one here. Which one did you go to next?
So
this
what
one
it gives, sorry, go ahead.
I was just gonna ask if you're gonna do this one or this one next.
So yeah, so what I did is, so it gives that you have to set like X3 and X5 as a constant. So I found, what I did next is I found the X4 value.
Okay, but we can write. So what I was gonna, let me just jump in here. What I was gonna tell you is that for each of these, you can do exactly what you just said.
Oh yeah.
So at point 2, the inputs are X1 plus X3 equals the outputs 150 plus X4.
Yeah.
Because those are the 2 out. And then we jump to 3. Okay, and 3, it's got X2 in plus 200 in equals X3 out plus X5 out. Now I see a problem all of a sudden because you're gonna have more variables than equations, but we'll deal with that in a moment. X4, you've got X5 in plus X4 in equals 350 out.
Yeah.
Okay. Now we're gonna solve this, but before we do that, you really want to write it so that it's in like standard form. So this is like X1 plus X2 equals 300. And then for the second one, I'll move this over. So it's X1 plus X3 minus X4 equals 150. And then this third one is, let's do, I guess we'll move that over. So it's minus X2 plus X3 plus x5 equals 200. And then this last one is x, actually let me move that one over a little bit. Last one is x4 plus x5 equals 350.
Mhm.
Okay, now we can get to the actual like help. So it says let x3 equal s, okay, and let x5 equal t. So let me copy this down. If these, and by the way, these are very complicated. These are things you would see in a college class, these systems. I really hope that copied. Okay, so just keep that in mind here. So they say, oh, x3 is s and x5 is t. Sorry, so let me just get this in here. Okay, so plus s plus s, and then x3 is t. Oh, I did that wrong. I'm so sorry. S, those are t's, those are t's. And why do they use s and t? I have no idea. That was just a convention someone came up with. So now x4, if we look at the fourth equation here, you always work backwards. X4 equals 350 minus t. So let me snip in the solution space, the thing they want you to enter. So you can see that. So x5 is t, x4 is 350 minus t. Okay, so now if we go to equation 3 here, equation 3, to solve for x2, so you have to move x2 right, the 200 left, it becomes x2 equals s plus t minus 200. And because that's s, this is s plus t minus 200. And then if we look at equation, is that right? I guess.
Yep.
Okay. So x1, oh, you can only write transfers in terms of s and t. Okay, I got it. So if we use this one here, maybe I'll make a comment about why this is useful. So number 2, x1 equals, that's a 150 up there, 150 plus x4 minus s. We can't have x4. x4 is 350 minus t. So this becomes 500 minus t minus s. And that's what goes in this position here. The reason you do all this is so that, like, if you were writing a program or you're trying to present this to someone, you could pick values of s and t that somehow made sense in this context and like show different possibilities. Okay. So if that's correct, Niko, I don't, you're welcome to check it.
Yeah, let me check.
The next part, you're just taking those values and you have enough to be able to solve for x2. Like, given these known values, you take your information here and you can solve for stuff. Oops, I didn't grab all of it. So like, you can, instead of x2, it's 180, x3 is 50. So that gives you the s value. That allows you to solve for x2 and so on, like that. Okay, so I think there's probably enough there. Jamie, jump back to you here. We did the golf problem, we did that problem. Looks like 14 is another one you sent. Is that one you'd like to go over, or is there something else?
Can we go over 14?
Sure. All right, let me snip this in. Okay. You probably won't get this on the exam in this format, but the inputs tell you the variables, X, Y, and Z. So a small corporation borrowed $325,000. That's your total equation. You almost always have a total equation. So X plus Y plus Z equals 325,000. That's the easy one. They tell you how much was borrowed at what interest rates, and they tell you the annual interest. So that's the interest equation here. And it's always percentage times amount. So that's 0.09x plus 0.1y plus 0.12z equals 33,400. And then there's some other information here, which I'm not seeing. Did I not snip it? Oh, the amount borrowed at, okay. The amount borrowed at 10%, I didn't even catch this. The amount borrowed at 10% was 2.5 times the amount borrowed at 9%. So the amount borrowed at 10% is Y. Y was 2.5 times the amount borrowed at 9%, which is, I'm sorry, X. So you got to pick some numbers here. So let's say X is 1,000. That means Y is 2,500. Is that reasonable? Is 2,500 2.5 times 1,000? Yes. And that's how you decide, which way to go on that. Now you have to have X and Y on the same side. So you can go X 2.5X minus 1Y equals 0. Okay, so why don't you guys enter this into your calculator and use the RREF, or at least Jamie, I'll have you do it. Niko, if you've got this problem, maybe you can just, the only
I'll do
numbers
the
that
numbers.
are going to change are going to be these two right here.
Yeah. Okay.
And then I'll do it as well, but I won't do it on a calculator. I'll just do it on this other thing and see if we all get the same answer.
You want us to message you when we're done or just hold on?
No, just verbally tell me. I'll snip in the what you should see. At least for you. You're done, Jamie?
Yeah, I
Okay.
got X equals 70,000.
Yep. Y equals 175,000.
Yep. And
And then
Z is 80.
80, yeah. Again, you should get nice numbers for this. If you don't, check check that you entered it correctly. Number one mistake is stuff like that. Okay. So I'm gonna go to like 25 or 26. Niko, do you have a preference?
Can we do 26?
Yes.
Thank you.
All right. So let's see here. We'll use muffins, bones, and cookies, MBC for variables. All right. And they're giving you the units of something. So it's probably going to be something equals beef, something equals chicken, something equals liver. So each muffin requires 2 units of beef, 3 units of chicken, and 2 units of liver. This one is a little odd. Back up here. Each muffin requires 2 units of beef. Okay, so let's go with like, this is really odd. You see. Jamie, do you have any insights here? You probably maybe already worked on this one.
This one confused me as well.
Okay,
I was just gonna solve it later today.
yeah, 2 units of beef, 3 units, each bone requires. Each bone. Okay. See, it's like the variables are beef, chicken, and liver. But now they're doing it backwards. Okay, let me. Two, 3, and 2, 1, 1, and 1. What's the other one here? 2, 1, and 1.5. Okay, so it's like 2 units of chicken, no, 2 units of beef, 2 units of chicken, 2 units of liver. See, that's not making sense. Okay, let me look, check the internet here. I don't know why these aren't. Let me try just solving this here, using some numbers in the computer here and see if I can get anywhere on this.
Okay.
And then get back to you guys. 2, 1, 2, 1, 2. And that's 1, 4, 5. And then 3, 1. 2 units liver. Okay, so the way I wrote this, I don't like, but let me just write the systems I wrote so you can kind of follow it. So it's 2x plus 1y plus 2z equals 1045, and that comes from the first number in each one, the units of beef. Okay, and then the second one here is 3x plus 1y plus 1z equals 940, and that comes from the second number in each one of them. And then the third one is the 2x plus 1y plus 1.5z equals 910, and that produces the following. It produces 165, 175, and 270 as solutions. I can't remember who was this yours, Niko?
Yes.
Would you be willing to try that just to
Yeah.
see if that works, and then we can maybe talk about why it works? Sometimes you just try something and see if you get decent numbers.
Hold on, it's loading right now. Yeah, it says that's correct.
Okay. I'm really bothered by this, but it's generally like whenever they give you numbers like this, it's always the right hand side. Okay, this is the right hand side, and then they tell you for a muffin it's M units of beef, and then for each bone it's B units of beef,
Mhm.
and so on. All right. Do you have any other ones, Jamie, you want us to work on?
Let me look. Looks. Oh, here's one. I'm gonna send one real quick.
Okay, I think we have enough time to do that.
Okay. One's going through right now.
All right, take a look here.
I mean,
Loading, loading, loading. Come on. So which one here? 4, 5,
4. Sorry about that.
4? So this is something quite a bit unrelated to these other problems, of course. So partial fractions decomposition. So there's some rules associated with this
Mhm.
that it depends on the degree of this thing here. So this resource I always like to use, it's Lamar University in Texas. They give you the actual forms that you need. I'm just going to snip those in. Mostly because I need the reminder because I don't do this very often. But it's a wonderful table. I'll just snip in the first 2 here, and I think it's very helpful. So yours is in this the second form, and I don't use A1s. I use A, B, C, and so on for these. So the decomposition here is that it becomes A over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed plus d over x plus 1 to the 4th.
Okay.
And then from here, you set this equal to 2x plus 5. Do you actually have to solve it or just write the form?
It looks like, so you don't, it says do not solve for the constants, so just write.
Okay. So, but here's the thing that like, I don't know what your instructor is going to, I don't know how this thing is graded. Like that you may have to do like A1, B, like, I don't know what to tell you to put in the top.
Oh, got it. Do you want me to?
So if you have like use another or see one like this, it'll tell you what it could look like in terms of like the answer so that you can see what to put in. I don't know what to tell you though. I don't know what it'll accept. But it's gonna have the bottom the way it is, but the top I don't know.
Okay.
Let me look at it one more time from your email and see if I can tell you anything useful. You don't have a so there's another box that these often have, which is like do one like this. Oh, use the variables a, b, and c and d for your constants. There you go. You have it. A plus b, c, and d. So there you go. It is that right over here on the right. What I'm showing here.
All right. Thank you.
Okay. That does take us pretty much to the end of our lesson. Guys got a lot here. So hope you guys can get all this done, but look forward to helping you guys again next time.
Awesome. Thank you.
Okay. I'll send the notes to screen recording out shortly. Thank you. Have a great night.
Thank you. You too.
Okay, bye.